Good afternoon. My name is John Thompson from a company called Birchnell Howden, and we're based up in Sheffield. I've been working with networks probably most of my IT career. I've been working with Router OS a very long time, working as a MikroTik consultant for about 6 years and a trainer for just over 18 months. We provide a whole range of services: desktop support, hosted services, training and consultancy. Now this afternoon I'm going to talk to you about some of the changes that has happened with the bridge configuration, and I'm specifically going to be focusing on the new 300 series CRS units. Now, when we first saw these, and especially the PoE model, we're quite excited to be able to use MikroTik as switches in the LAN. And I'm going to go through this presentation. We're going to look at some of how you do VLANs, specifically on the 300 series switches, using the new VLAN filtering in the bridge. And also, I'm going to talk about some of the common things that you may do wrong in the layer 2 configuration in the bridge that will cause you problems. I probably really should have brought Mike into this presentation, but Mike didn't do the configurations here, but maybe next time. Since last week, 6.42 became the current version, so the current version now has the new bridge configuration. Just before I go into this, looking at the 300 series units, we get a lot of people come to us and say, well, I've got this and it's not more powerful. So I thought I'd just do a quick comparison of some of the two high-end units that we've used on a project recently and show that power and CPU isn't necessarily the best way to go. So I've taken two high-end MikroTiks, taken the CRS 1072, 72 cores, 16 gig of RAM. If we put it against the CRS 317 with considerably less CPU grunt and a lot less RAM, you may wonder which unit is best. One has a cost price of about $3,000 and the other one is $400. And there is a big difference that if you were to go and buy those, you may have wasted a lot of money, or you may have bought the wrong unit and wonder why it doesn't work. Now, if we look at the stats, and on every MikroTik device, you can go on the PDF pages on the website, and you can see all the stats there about the unit. See here, the 1072 will get us about 80,000 or 80 gigabits per second at layer 2, and about the same at layer 3. But if we look at the CRS 1317, we can get somewhere double the layer 2 throughput, but a fraction of the layer 3. So it's very important not to think that the MikroTik is no use, but to buy the right unit for the job. If I'm going to do layer 2 in my LAN, there's no point spending £3,000 on a 1072 just to get 80 gigabits throughput, where I could spend $400 and get something that will get me more layer 2 and save me a small fortune. Here you are. CRS has double the layer 2 throughput and is just over a tenth of that cost. So I know there's been presentations other years and I've seen people talk about it, but I'm going to go through how we are going to use this CRS, and mainly we'll be using the CRS 326, mainly the PoE unit, because we do a lot of installs with desk phones and wireless access points. We want the power and the PoE outputs. If you would now use anything newer than 641 to the current version of 642.9, you will have noticed in the interfaces that this master port has now vanished. And if you haven't, when you upgrade, you will see that this setting has now gone. And all master-slave configuration previously done on the interfaces to use the onboard switch chip if the unit had a switch is now done by creating a bridge. You know, anything from 641 onwards is not there. And as long as you've got a bridge and you've got that magical box there ticked saying use hardware offloading, and if the ports that you have put in the bridge are connected to the same switch chip, and you don't use any other feature that will disable this, and I'm going to talk about these later on in the presentation, you will get HW offloading on the bottom right, or you'll get a H flag showing up on your interfaces page to show that it is now using the switch because it can. Now, if you are upgrading routers from older versions to 641 or newer, it does upgrade automatically and it does create a bridge. However, sometimes I have seen routers create blank bridges and not put the ports back in. I've also seen routers upgrade and not apply hardware offloading because of particular configs on them. So if you are upgrading, if you can, remove the master-slave configuration before upgrading, or at least once they have upgraded, log straight back in again and check that you're using hardware, because you're going to wonder why your throughput is considerably slower than what you had previously. Since the new version with the new bridge configuration, there is a lot more settings now in the bridge. Some of this has started at 641, and there are more features added in 642 and 643, and new features are continually being added to the bridge configuration. Now check the release notes and you'll read all these features, you'll see what's going on. The documentation is being updated as they are added. Now, different switches still need different MikroTiks still need bridges and VLANs configuring differently, and the setup I'm going to show you for VLANs using the bridge filter for VLAN configuration is very specific for the CRS 300 series because it is the only units that currently support hardware offloading using VLAN filtering on the bridge interface. If you use other MikroTiks and you are trying to use them as a switch with VLAN filtering, and you apply the VLAN filtering that I'm going to show you, and you need to do layer 2 switching through it, you will get the slower path through these as the traffic will use the CPU, and that H flag will disappear. So there are some other features on the other units that disable the CR, I'm not going to talk any more about them, but the CRS 100 or 200 switches, as soon as you enable VLAN filtering and some other features, will then disable hardware offloading. And there is a lovely table here, and it's also in the wiki, and this tape shows you also using the switch chips that you find in other router boards. If you enable features on the bridge, they will disable hardware and not use the switch chip and pass all the data slowly through the CPU. So what I've done here, I've created a simple setup that will mimic a lot of what we would do for our clients in their offices, to use this as a switch in the enterprise and our clients' offices to run their networks. And I've set up here, I've just used the first 8 ports, and that was primarily just to keep the configuration and the CLI short for this presentation, but obviously we would configure more ports in the real world. So what we've done is on this configuration, we've configured ports 1 and 2 as uplink ports, one up to my router and one to my next switch should I have one. And I have created some access ports for my users and servers and I've created one in the public VLAN for a public device, probably the plasma screen in reception, showing some news channel or other information. We're going to set up 3 VLANs for this, one for public, one for our data, for our private network, for our staff to use, and a third VLAN is going to be used for our phone traffic, so we can segregate our network. Talking about what people have done with the security, we're going to segregate our traffic on our network. Now, strong tip here, when you're configuring VLANs in the bridge filter, we start with the configuration, but do not enable VLAN filtering until we have finished. I tried this, turning it on first, and I locked myself out of the switch and I couldn't get back into it, and I had to get my serial cable out to get into it. So from bitter experience, build the config, then enable it, probably with safe mode, and then if it all goes wrong, you've only lost one change and you can get back into it and work out what you did wrong. So we start with a single bridge. We only need one bridge now on the 300 series switch to do VLANs. We create a bridge, then we add all the ports. Now, you could add them manually, you could add them in the CLI, or you could use scripting, as we've seen earlier on this afternoon, to add the ports for you, and you saw how much quicker that would be. When we get 48 port switches, it's going to be the 20 odd seconds to write the script versus 2 minutes of your time, so you've saved a good 1.5 minutes there if you script it. When you add them, it is a default setting, but make sure you're adding ports and using hardware offloading. Once we've created the bridge, we can then create our VLANs, and we create the VLANs in the bridge menu now. And then, because we're going to use some tag traffic on our uplink, we will tag the traffic on Ether 1 and Ether 2. Another configuration tip, if you are using Winbox, you can show some extra columns that aren't on by default. You can see add in tagged and untagged ports. Those are the ports that you've configured to be tagged and unported. So while a port is either inactive or not using it for some reason or the other, you can still see on that screen that you've configured it, not just seeing the ones that are currently used, which is much more useful in my opinion. And we add the ports, and now we can see that there is some configuration on it. Then we'll configure our access ports, or our untagged ports for our users to go into. I'm just going to configure for this purpose, but we'll get the idea that you can apply this to other ports. Now, we want to put our phones in VLAN 11. No, in this example, 101, and our data in VLAN 10. Now, the phones that we most commonly use, the configs are locked to us by our SIP provider, so we can't edit the network ports easily in them. So we want to be able to use the port in the back to save on switch density to plug a computer in, but still segregate the traffic. Now we can do that on a MikroTik as well by creating a Mac-based VLAN. So I create, because all my phones from the same vendor, and because they most likely come in the same batches, they're going to have the same OEI part to my Mac. The first 3 octets of the Mac are going to be the same. So here's an example using a MAC address and a MAC mask to create a switch ACL rule that will set any traffic coming from those source MAC addresses based on that mask into VLAN 101 for me. Okay? Now, because it is untagged traffic coming from the phones, it has not got a tag on egress into the switch. We need to make those ports untagged in both VLANs. Seems a little bit not quite right, but it is still, though we've created a rule, hasn't the traffic doesn't come into the switch tagged, the switch will add the tagged for us, based on that switch ACL rule. And then, because any traffic coming into the switch port that from our computers will also be untagged, but we have no rule to tag it because I don't really want to try and find the MAC addresses of every vendor's of laptops, our desktops, our clients are using, because I don't really need a VLAN for each Dell machine, a different VLAN for HPs, a different VLAN for Apple devices. It seems a little overkill. We will set a PVID to add the egress tag to all the other traffic coming in on that port, but the switch ACL will override that for the matching MAC. Okay, so we add the PVID of 11, for this example is my data VLAN, to those ports. And almost identically, created one port that is just in the data VLAN, VLAN 7. It's as simple as just making it untagged in the VLAN and adding the PVID. For those people who work regularly with switches, this is starting to look very similar to other vendor switch configurations. And the same, I've put port 8 into a different VLAN, I've made it untagged, and I've put a different PVID because that's where I want the traffic to go. Now, it's all well and good having this switch running. We've got our data on it. We've got our VLANs, we've segregated our public, private, and phone traffic. But I'm rather hoping that you don't want to just put this switch in a cabinet and forget about it, that you're probably going to want to log into it once in a while. The clients tend to want things changing. You're going to need to periodically log in and update router OS on it, because you need to, and other things. So you probably want to log into it without getting your serial cable out and going to site every time. So we need to put an IP address on it. Now, for the simplicity of this presentation, we are going to manage it from the private network, but you could also create another VLAN for management and do almost identically to this with a different VLAN. So we create ourselves a virtual VLAN interface using the normal way that we've done in router OS, but we create it on the bridge, and we set a VLAN ID of 11 because that's the VLAN that we are using, and this becomes attached to the bridge, not to any of the interfaces, and that's important. Okay, and because we have created that interface and have tagged the traffic at that level, it is egress tagged through the switch CPU. So what we do is we add the bridge interface as a tagged traffic, not the virtual interface untagged. You must add the bridge as tagged traffic, and then the management will be on VLAN 11 because there is a virtual interface then, and then you can either set an IP address manually like I've done there, or you could run DHCP server on that VLAN interface and it will obtain an IP address in the correct VLAN. And then once we have finished all this configuration, and if you're unsure because you haven't done very many, at this point might be a good idea to now put safe mode on, then click enable VLAN filtering, and only once you've got the configuration that you want. And then if you're going to use it, and it's probably a good idea based on all the security talks that we have done, apply ingress filtering correctly to the ports you've got so that you allow only tagged or untagged traffic as required on the ports, allow the configured VLANs only using ingress filtering, that I don't have time to go into all the details of that this afternoon, but that way that you'll reduce unknown traffic, it will make your network more secure by not having random VLANs flying around and coming into your switch. You're going to drop them. And you can allow everything which is the default, which I would not recommend once you have got it working. Then you can allow on a port by port basis tagged and tagged traffic as required. And if you admit only tagged, it will only permit the tagged as configured on the VLAN table. Okay. And that is the configuration that applies to the 300 switch. If you apply that VLAN configuration to any of the other CRSs and use them as a switch, then you will then have all your traffic passing through the CPU much slower than it would have done using the VLAN configuration on the switch menu. Though this does make a very good configuration if you are doing the equivalent of router on a stick, where you're not using the switch ports for routing, where you're using the ports purely for routing and not switching, then this makes a very easy way to configure a router for your engineers, in my opinion. And you don't need the switch chip to pass it, so it can go through the CPU anyway. So, while preparing this, I tested a lot of things and did a few things wrong, intentionally, to see what would happen. So here are some of the most common layer 2 misconfigurations that I have seen or experienced while doing this. These slides show, firstly, the incorrect configuration. Don't follow the incorrect configuration, followed by the correct. Here is a scenario. You have a CRS 300 series switch. You want to isolate ports from each other. This could quite well be Mike doing this, but I should have put him in. So you decide to create 2 bridges. Okay? As a bridge is a separate layer 2 domain, you have isolated your traffic from each other and done what you set out to do. Symptoms, however, you start using the switch. We start passing lots of video through our switch ports. And you notice that one set of your switch ports pass traffic really quickly. Great, you've got the throughput you'd expect. But then the other set of ports in the other bridge do not. You test further, and you notice that sometimes when you're passing traffic, the CPU becomes really high, and traffic still flows slowly when the CPU gets high. So then we need to start looking at the configuration. And you notice here, on this screenshot, I've got some ports in bridge LAN, but then I've got ports 17, 18, 19, through to 22 in bridge 1. And if you look closely, and you can probably spot based on what I've talked about earlier, but we now see that those second bridge ports have no H flag. The 300 series switch only supports one bridge using hardware offloading and that switch chip. The CRS 100 and 200 does support up to 7 bridges using hardware offloading. So if you're using a 300 series switch, then the correct configuration here would be to apply VLANs and VLAN filtering using VLANs in the bridge menu, as I showed earlier in the presentation. Another scenario. You want a DHCP server to give out IP addresses, or you want a DHCP client to only work on certain VLAN. Okay? So you create a VLAN on the interface where it is, or where you want it to hand out. So I've got Ether 1 connected maybe to another switch with VLANs on it, so I create VLAN 11 on Ether 1 because that's the port that's expecting to receive tagged traffic going upstream. And then this is a screenshot of a DHCP client running on Ether 11, but you do the same as a DHCP server. Now, fortunately, the DHCP client in this scenario has actually gone red. They don't always show you that they're not working. But because that port is on a slave port, not the master interface, the traffic is immediately forwarded before packet processing is done. And if that was a DHCP server, sometimes it does occasionally hand out an IP address, and sometimes it doesn't. If you've lost your IP address, or you created the IP address on on that virtual interface, you can't get back into your switch. I tried. I had to get my serial cable out again. The solution is exactly as I showed in the management in the management configuration of the switch. You need to move that VLAN to the master port, which in this, with the bridge VLAN filtering on the CRS 300 switch, is the bridge interface itself. And then it worked again. The DHCP server worked, the DHCP client worked, and I could get back into the unit on an IP address. Similarly, if you want to send traffic tagged out of a port, so we want VLAN 11 traffic tagged out on Ether 3 in this screenshot. This works quite a lot of the time. However, you will run into problems if you are running spanning tree. Now, we have to run spanning tree or loop protection on our networks because the number of our clients' users who go around, see a random loose cable and plug it back into the phone on their desk or an empty wall port or anything they can find and take the LAN down. So we need to run spanning tree. If you send that traffic tagged out on that interface by creating that VLAN again on another slave interface and adding that VLAN, my pointer's working, and I've added that VLAN into the bridge as a bridge port so that it receives my tag traffic and untags it inside the switch. What you have done, hang on, I'm going backwards, sorry. What you have done is you are sending out of Ether 3 in this scenario, tagged BPDU packets for spanning tree. Most of the vendors, and a lot of the time even MikroTik, do not understand BPDU packets with a VLAN tag at the beginning. The symptoms you will see is sometimes ports blocking, ports flapping, you will get network loops when you don't want them. The solution, believe it or not, is use VLAN filtering, as we have just looked at, and set the PVID on the interface on the bridge to tag that traffic, but not add a virtual interface into the bridge. And then spanning tree, or rapid spanning tree, which would be my recommendation, use the newer version, works absolutely fine on these switches and going to other vendors' switches on the ones I have tested, fine. Okay? My final misconfiguration, bridged VLANs. Now, we've done this, I've done this configuration myself, but so what I have created here is I have created two VLANs on Ether 2, or Ether 3 and Ether 4. Possibly these are going to other switches, bringing in tag traffic. What I want to do is make sure that VLAN 11 and VLAN 101 traffic is obviously joined together correctly. So this is this configuration will work. And what I have done here is I created two bridges called Bridge VLAN 101 and Bridge VLAN 11, and I put those virtual interfaces in it. However, it does cause some problems if you do it. It works some of the time. You will notice that some parts of the network go down from time to time. You will notice that some of your links keep flapping. And yet again, what we have done here is we are sending out tagged BPDU packets. Symptoms, port blocking, port flapping, parts of our network unreachable. So there is a solution to this. There's two. One, disable spanning tree protocol on the bridge. Then that configuration will work. But you lose the advantages of spanning tree gives you to prevent your users from doing silly things. It's all well and good if this switch is just in kit that only you ever use and manage, but as soon as you put them in the enterprise where there are users do things that you don't want them to. So If we want to keep using spanning tree, then use the bridge VLAN filtering as we have looked at, use a single bridge, and you will still have spanning tree and it will work. There are some more new features that you can do in 643, and this is one that when I saw this in the change logs I got really excited about. This is another problem that we run into on our clients' networks quite regularly. A client thinks there's not enough Wi-Fi at my desk, or I need some more switch ports, and they see at home they've got their old broadband router. It's got 4 ports on it and it's got Wi-Fi, and they think, great, I'll bring it into work. They plug one of the Ethernet ports into it, into the cable that they've got from the wall from their IT company, then they plug their desktop into it, and they plug their laptop into it, and then they've got Wi-Fi by their desk. They can have their mobile phone and their tablet on the Wi-Fi. However, all these routers out of the box have a DHCP server running on them. And we found, I mean, I've been to jobs, I went to one client site and we found that they managed to plug in 4 extra routers into their network, and they had 4 DHCP servers running, all doling out 192.168.0.0 on a 24, giving the same default gateway. We never quite worked out how that network ever worked, but it was, for some reason. And I got quite excited by this, that we can now do this on MikroTik. Since 643 release candidate 56, it's now in the final release of 643 that went into current tree a week ago Monday, I think, 2 weeks ago. We have DHCP snooping. DHCP snooping is an amazing security feature, but also a great feature to prevent problems in your network, to reduce engineer visits to site, to spend hours with networks down while you diagnose problems and work out what your users have been playing at. And what this does is it limits the ports on which DHCP offer requests come back in on. There are hackers who will use DHCP as man-in-the-middle attacks in various scenarios, and they will prevent people communicating on the network by giving them an invalid address or handing out an invalid DNS server so they can control your DNS. However, most of the problems we run into is really down to people plugging routers in incorrectly, but this does happen. And so DHCP, quick recap for those who aren't so familiar with it. Your device, computer, laptop sends a discover packet out. The switch, it's a layer 2 packet, so it's forwarded out of all switch ports. And it is simply as down as whichever offer comes back first is the one that your laptop device gets. We put our dear friend, the hacker, in the middle of this lot, if this was a security problem that you're also now protecting against. We've talked about security quite a bit today. So this is a layer 2 security feature. Our dear friend there can then receive your discovery, and he can also send a second offer out. Now, he could send out a different IP address and a different gateway, and he could route your traffic. He could just send you out a different IP address and you get no traffic because the gateway doesn't exist. Or he could give you out a valid IP address on the network, but change your DNS server. So he is in control. Now, fortunately, and then you'll still go to the site, and as long as the SSL certificate is valid, you've gone to the name. Even SSL sites, still, as long as the name matches what comes back, hasn't prevented against this, and I've picked some random English bank that we've given out a different IP address to, and he has received your requests without you having to click on a link in an email or use a search engine that gives you dodgy responses, but you've typed the address in, you've done the lookup, but to a new server and got the wrong response. It does happen. You can use it to protect against our networks, because we know in our networks, when we build them, which ports have the DHCP server on, until the clients repatch the network when you're not there, but then at least then you've known they've done it. And as you saw in the table I put up very quickly earlier, but this is a quick snippet from it, that the CRS 300 series will still use that switch chip with hardware offloading with DHCP snooping. And there are more things that you can still get hardware offloading from that 300 series switch and still get the throughput. So I'm going to very quickly, because I know we're getting very late in the day and there's still another presentation after me, and these slides I will have uploaded later so you can see them, but the next couple of slides just show you the configuration to do DHCP snooping. I've dwelled on that new feature because I'm quite excited being able to use it, and it will save us a lot of time with support hours. And all we do is we create the ports, and in our configuration it was 1 and 2, 1 goes to our router and 2 goes to the next switch. Those are the ones that we are expecting DHCP responses on. And it's always the ports that go to the DHCP server or another switch, and those are the only ones. You tick this box here that says trusted, okay? That's for DHCP, okay? And then on the bridge, it is as simple as enabling DHCP snooping. I do strongly recommend, in the same way as the VLAN, you create the trusted ports before turning on DHCP snooping, because otherwise DHCP won't work. And there you are. Some other features in the new release in 6.43 that you can see and read about. BPD guard, protect which ports do and don't participate in spanning tree. IGMP snooping, but there are quite a lot of the settings of that in the CLI only. When you look at the release notes and see the new features, when they first bring that feature out, it is more than commonly CLI only, not in Winbox, so you won't necessarily spot them straight away. The 300 series switch also now supports hardware offloading for bonding, 802.11ad, there's a typo there, and the balance XOR. And I know the guys today talked about scripting and how we could add all those ports quickly into a bridge, but I might take that one step further and create that into an address list, and you can now add address lists into the bridge. So you've got one point where you've referenced all your LAN ports, and then you can just put those into the bridge, and you could use that elsewhere on router should you wanted to save creating all that port list multiple times. And also new 643 multiple spanning tree. You now do spanning tree per VLAN, so you can have different ports as active or inactive for spanning for different VLANs, so that you can load balance across your networks more efficiently if you're using spanning tree. There is DHCP option 82 support, and there is more stuff coming. Read the change logs. Thank you for listening.
Thank you. Do we have any questions? Thank you, Jono.